Hey, today we're talking about 4.3, which is a phase shift. Now, a phase shift is just a very fancy way of saying, hey, I'm going to pick up my graph and move it left or right. And it's this C value here. Notice that my C value is just subtracted from my X value inside these parentheses. That's going to come as an important fact later. But the important thing is X has to be alone, and we'll look at that a little bit more later. But to start things off, let's remember shifting graphs left and right from algebra 1, algebra 2, whatever you saw it in. If I wanted to shift x squared to the left, right, to the negative x direction, I had to add, say, a number, right? If I want to shift it 2 to the left, I had to add 2. That's to shift it left. If I wanted to shift it 2 to the right, I had to subtract 2. That's to the right. So it's kind of this opposite thinking that we have to remember. Want to go left, we add a number. Want to go to the right, we subtract a number. It's going to be the exact same today. So let's look at this quick. I want to first find the amplitude, period, vertical shift, and phase shift. Those are the key 4 things we're going to be looking at in every one of these problems. Amplitude, period, vertical shift, and phase shift of this graph. Y is equal to sine of x plus pi over 2. Well, okay. You immediately see that we're adding to x. So we're going to be shifting to the left. So let's write out everything now. My amplitude, well, we are not multiplying by anything other than 1, so it's 1. My period, remember it's 2 pi over b. b is 1, so it's just 2 pi. My d value, or my vertical shift, we'll write it vs, just to clarify that it's a vertical shift. My vertical shift is 0. We're not adding anything on the end here. And then my phase shift, it's that new value. It's whatever C value I have, but it's x minus C, so I'm actually shifting it negative pi over 2 since we're adding pi over 2. It's that backwards thinking again. So let's graph the parent sine function just to clarify what we're doing. Right, my amplitude is 1, so between 1 and negative 1, I have my 4 key points because I have my normal period. So pi over 2, pi, 3 pi over 2, and then 2 pi. And my parent sine function would be here, here, down here, and right here. But because we're phase shifting it to the left, pi over 2, I first have to look at my increments. Well, each of my increments is pi over 2 away from each other, so I'm just going to shift it 1 increment to the left. Now all of my points are just going to shift 1 increment to the left. So this one goes here, this 0 value goes over 1, this negative 1 value goes over this way and over. And this is my phase shifted sine graph. And we've got to make sure we've graphed it over the right interval. My interval is negative pi over 2 to 3 pi over 2. Well, I start at pi over 2 and go to 3 pi over 2, so it works out just great. Another one of these, if I want to graph cosine of x minus pi over 2, immediately you notice, hey, we're subtracting from x. So I'm going to write out all 4 of my key values that I need to know. Amplitude is just 1, not multiplying by anything fancy. Period, no b value is 1, so I have my normal period of 2 pi. My phase shift here, remember we're subtracting pi over 2, so it's a positive pi over 2, so we're shifting to the right, and then a vertical shift of 0 since we're not adding anything on the end here. Let's plot out my normal parent cosine function points. So I'm between 1 and negative 1 since we're not multiplying by any amplitude here. So at 0 I'm up at 1. Oh, I got to graph my key points. Pi over 2, pi, 3 pi over 2, and then 2 pi. Remember, key points of a normal period. At pi over 2 I'm at 0, pi I'm at negative 1, 3 pi over 2 I'm at 0, 2 pi I'm up at 0. Up at 1. Careful now, we're shifting pi over 2 to the right. So we look at my increments go up by pi over 2, so I'm just going to shift it 1 increment to the right. So this value comes over to pi over 2, 0 value right here, move this one over to the right, this one moves get over to the right. So I have to add 1 more increment because I have to move this one over to the right. So what's 1 more pi over 2 from 2 pi? Well, that's 5 pi over 2. And that value goes there. And we have my cosine function that has been shifted pi over 2 to the right. So this one looks like a mess. Now remember right away what I said. I have to add my c value or subtract my c value from a naked x, or an x that is just multiplied by 1. Well, I'm multiplied by 2 right now, so I have to factor out a 2 from this entire parenthetical. So my 3 sine, now I'm going to factor out a 2 to get x by itself, and what am I left with when I factor out a 2 or divide by 2, so multiply by a half, I have a plus pi over 4. And then I have no vertical shifting. So let's write out all 4 of my key values again. Amplitude, well that's 3. My period, my b value now is 2. So I'm going to have 2 pi over 2. And my new period is pi. Vertical shifting, well I said I have no d values, so my vertical shift is 0. Now my phase shift is whatever I'm adding or subtracting to x. Since I'm adding, it's going to be a negative pi over 4. Okay, let's graph this sine function without the phase shift. Because we all know how to graph 3 sine of 2x. My amplitude is between 3 and negative 3. And then how far are my key points going to be away from each other? Well, my period of now pi divided by 4 key points, pi over 4 away from each other. So I'm going to have 4 of them. Pi over 4, pi over 2, 3 pi over 4, and then 1 pi. Since we're a sine, we're going to start at 0, go up to my peak, back down to 0, down to my valley, and up. So those are the key values for my 3 sine 2x. But remember, I'm phase shifting it negative pi over 4, so I have to move everything over 1 increment, since my increments go up by pi over 4. So I had to add 1 over here. This one comes over here. This value comes over here. This 0 value comes over 1 increment, over 1 increment, and then over 1 increment. And now I just connect the curve. Now let's make sure we fulfilled our bounds. We're going from negative pi over 4, which is right here, to 3 pi over 4, which is right here. So we're good there. Alright, let's do one more of these. We're going to graph 2 cosine 3x plus pi. Now remember, I have a value multiplied by my x value, so I have to factor that out. So I'm going to factor out a 3. I'm left with just an x. I have to multiply by 1/3 to figure out what my new value is, because I'm factoring out a 3. So plus pi over 3. Let's write out all 4 of my key values. My amplitude is 2. My period, which is my original period, 2 pi divided by b value, which is 3. Ooh, that's an awkward period. 2 pi over 3. Well, we'll deal with that in a little bit. What's my phase shift now? It's my value that I'm adding or subtracting from x, so it's a negative pi over 3, since we're adding it. And vertical shift, again, we got nothing, so it's a 0. So let's graph out 2 cosine 3x. So everything that I have without my phase shift, and we'll just see what happens. So my amplitude, I'm between negative 2 and 2. Now I'm going to have my 4 key points. Well, what are those key points going to be away from each other? It's my period, so 2 pi over 3 divided by 4, or I multiply by 1/4, I get 2 pi over 12, or pi over 6. So my key points are going to be pi over 6 away from each other. Pi over 6, 2 pi over 6 is pi over 3. Keep messing that one up. Pi over 3. Then 3 pi over 3, or pi over 2. And then 4 pi over 3. Nope, that's not right. I am not been able to do mental math today, apparently. Let's think about this. Pi over 3, that's 3 pi over 6, 4 pi over 6, or 2 pi over 3. There we go. That makes more sense. So remember, it's cosine, so we're going to start up at my peak, go down to 0, go down to my valley, 0, peak. Now let's think about my phase shift. It's negative pi over 3. But you got to remember, how much does each of my increments go up by? Pi over 6. So to get pi over 3, I have to go to the left now 2 increments. Negative pi over 6, negative pi over 3. So now everything's going to move over 2 increments. 2 increments. 2 increments. 2 increments. And then 2 increments. Now we just connect it. And that's my phase shifted graph. So this one looks disgusting. Immediately you notice, okay, my x is not alone anymore. So I'm going to have to write out, I'm going to have to factor out that 2. So it's my new function is a negative 4 cosine. I'm going to factor out a 2. I'm going to be left with x. And when I take a 2 out, or I can multiply by half to figure out what the new value is, 3 pi over 4. And that's subtracted. And then I have a vertical shift this time of 1. So let's write out all 4 my key values again. A, amplitude. Well, it's the absolute value of that negative 4, so 4. The only thing that negative sign does is it flips it, and we'll do that right away just to get it out of the way. My period, which is 2 pi divided by b, so just pi. Phase shifting. Well, my x is subtracting a 3 pi over 4, so it's a positive 3 pi over 4. And then a vertical shift of positive 1. So let's graph this negative 4 cosine 2x plus 1. So essentially everything without the phase shift, because I just really want to emphasize what the phase shift does this lecture. We know how to graph the other ones without phase shifting. We spent all last lecture doing that. Okay. So how far are my key points going to be away from each other? I know amplitude-wise I'm going to be in between negative 4 and 4. But where are my key points going to be? Remember, it's my period, so pi divided by 4, so pi over 4 away from each other. Pi over 4, pi over 2, 3 pi over 4, and then pi. Now what this vertical shift is going to do is it's going to raise it up 1. Well, we'll do that in just a second. What the negative sign is going to do is going to flip my normal cosine function. So instead of starting up here, I'm going to start down here and then go up. So your normal cosine looking function just flipped. So this vertical shift of 1 just raises each of my points up 1. So instead of being a negative 4, negative 3. Instead of being at 0, at 1. Instead of being at 4, at 5. It's going to get a little cramped up there. That's okay. Instead of being at 0, up at 1. Instead of being at 4, negative 3. So the blue points represent what my curve is going to look like if I don't phase shift it. That's negative 4 cosine 2x plus 1. Now what happens when I phase shift it by 3 pi over 4? Remember, each of my increments goes up by pi over 4. So I need to shift everything to the right 3 increments. 1, 2, 3 pi over 4. Alright, so let's grab another color. I like orange. No, let's go teal. Teal's a nice color. So instead of being at 0, it's going to be phase shifted all the way over here. So I'm going to need to add some more increments. 3 of them, actually. So 5 pi over 4, 6 pi over 4, or 3 pi over 2. And then lastly, 6 pi over 4, 7 pi over 4. Okay, this gets phase shifted 1, 2, 3. Phase shifted 1, 2, 3. And then that'll be down here, phase shifted over right there. So this is one full cycle of this cosine curve. Y equals negative 4 cosine 2x minus 3 pi over 4 plus 1. So remember, don't get intimidated by the numbers. Write out your 4 key values that you need, and then just take them one at a time. So this one looks very fun. Negative secant 2x minus pi over 6 minus 3. Again, you notice right away, I don't have a naked x, so I got to factor that out. Y is equal to, well, negative secant, factor out a 2, x minus, multiply by half to figure out the new value, negative pi over 12. And then a minus 3 stays at the side. So let's write out my, again, 4 key values. Amplitude is 1. Remember, there's a negative sign. All that does is it flips it. We'll deal with that right away. Get it out of the way. Period. 2 pi divided by b, which is 2. So I got a period of pi. Let's do the phase shift next. The phase shift is, well, it's x minus pi over 12, so it's a positive pi over 12, or pi over 12 to the right, and then vertical shift of minus 3. Okay, remember, whenever we graphed secant, how do we start? We started by graphing its reciprocal, and then drawing from there. So I'm actually going to graph y equals negative cosine 2x minus pi over 12 minus 3, and then just draw my secant off of that. So my amplitude, well, okay, that's just between negative 1 and 1. What are my key values going to be away from each other? 1, 2, 3, 4. Well, it's my period, pi, divided by 4 key points, so they're going to be pi over 4 away from each other. 2 pi over 4, pi over 2, 3 pi over 4, pi. So if I were to graph this normal cosine, this flipped cosine, it starts at down low, comes up, down, and then down for one more. So that's it without the vertical shift or phase shift. What happens when I vertically shift it minus 3? Well, that just moves everything down 3. So we're going to move way down here. So instead of being at negative 1, we're going to be at negative 4. So 1, 2, 3. So that's at negative 4. Instead of being at 0, minus 3. Instead of being at 1, at negative 2. Instead of being at 0 again, we can figure this one out. And then negative 4. And then lastly, my phase shift. Remember, my phase shift is pi over 12. Let's look at what my increments go up by. Pi over 4. How many pi over 12s are there in pi over 4? Let's divide or multiply pi over 4. Divide by pi over 12 or multiply 12 over pi. Pi. Pi's cancel. 3. So there are 3 pi over 12s within pi over 4. So all I'm going to shift it by is a third. A third of one interval. So this will just get moved over a little bit, over a third of an interval, over a third of an interval, over a third of an interval. Okay, so this is my graph of negative cosine 2x minus pi over 12 minus 3. But remember, what does secant look like based on my curve? My secant shares my peaks and valleys, and then at every other interval, every key point, in between my highs and lows, there's an asymptote. And then from my highs and lows, it just follows the parabolic motion going down, and then up, and then down again. So that purple curve is what I need. That's my answer. Remember, you have to draw on your asymptotes. Otherwise, it's not correct. Let's do one more. Very fun one. 2 times the tangent of 2x plus pi over 4 minus 1. Again, you notice right away, hey, I don't have a naked x, so I got to factor out a 2. We're going to kind of go a little faster through this one. X multiplied by 1/2, I get plus pi over 8. And then I have a vertical shift of negative 1. Let's write out my key values. A value is 2. My period, remember, my original period for tangent is pi pi. So I have to take pi divided by 2. So my new tangent, my new period for tangent is pi over 2. Phase shifting. Remember, I'm adding pi over 8, so it's a negative pi over 8. And then vertical shift, my vertical shift is a negative 1. Okay. Let's start by graphing the period. Remember what happened with tangent? Half of my period has to be on either side of the y-axis without a phase shift. That's how it has to happen. So I'm going to have my asymptotes. Where are those asymptotes at? Well, half of pi over 2 to the left, half of pi over 2 to the right. So it's a negative pi over 4, pi over 4. Okay. Now, what does tangent look like originally? With tangent, what I had was it went through 0. 0, 0 is a key value. And then my other key values were halfway on either side in between my period. It went up to 1. Usually it went up to 1 and then down to negative 1. However, so I'd have a point here and a point here. However, because of my amplitude change, all those y values have to be multiplied by 2. So this is actually up at 2 and then negative 2. And then it would follow in that disco motion. However, with my vertical shift, everything is shifted down negative 1. Sorry, just down 1, not down negative 1. So this point moves down to 1, down to negative 1, and then down to negative 3. And then lastly, so this is everything without the phase shift, sorry. I have to move everything to the left pi over 8. Now when I say I have to move everything, that means I also have to move my asymptotes. All of my asymptotes, all my key points, everything, they move over to the left pi over 8. So what happens when I move my one asymptote over? It's negative pi over 4 and another pi over 8 to the left, so it's 3 pi over 8. When this key value moves over, it actually moves over on top of my original key points, but it's pi over 8. Then all my points move over. This moves over pi over 8 to pi over 4. This one moves over to here, and then this one moves over here. And then we just connect it. And that teal curve is my answer. Remember, the thing that was different here than the rest of the problems was that when I phase shifted pi over 8, even my asymptotes changed as well. They moved. So you have to move everything. So go ahead and write a summary and any questions you have, and take a look at the assignment for tomorrow.